Hi everyone, I'm Mohamed Naguib, a cybersecurity researcher with over 19 years of experience in information technology and cybersecurity. Welcome back to our cloud security mastery course. As you know, in this series, we're taking a structured approach starting from the fundamentals of cloud computing and gradually advancing into the critical aspects of securing cloud environments. Whether you're seeking to be a cloud architect, DevOps engineer,
DevSecOps engineer,
or an aspiring cloud security engineer, or cloud penetration tester, this course is designed to give you the deep practical knowledge you need to excel. So let's start now. Lecture Introduction to Cloud Computing Fundamentals. Let's begin our deep dive into cloud computing. I'll explain this concept thoroughly so you develop a strong foundational understanding. Definition of cloud computing. Cloud computing represents the on-demand delivery of computing resources, including processing power, database storage, applications, and other IT services. The critical aspect here is the demand nature. You obtain resources precisely when you need them through a cloud service platform with pay-as-you-go pricing. This means you pay only for what you request. You pay only while using the resources. Payment stops when usage ends. This represents a fundamental shift from traditional computing models. Key characteristics of cloud computing: precise resource provisioning. We can deploy exactly the type and size of computing resources needed. Need a large server available immediately. Require a small instance. Ready for use. Need 10 servers today, but only 2 tomorrow. Easily accommodated instant access. Resources become available not in 24 hours, not in 2 hours, but within seconds of request. Comprehensive interface. The cloud provides user-friendly access to servers, storage solutions, databases, complete application services. Cloud service model, specifically examining Amazon Web Services, or AWS. AWS maintains all network connected hardware. Users provision needed resources via web interface. This makes cloud capabilities immediately accessible, contrast with traditional IT. Previously, organizations would build and maintain their own data centers, purchase all hardware upfront, manage everything on premises. With cloud computing, we use shared data center infrastructure, provision only needed servers S1, 2, 3 as required, pay only for actual usage. Everyday cloud examples. You've likely used cloud services without realizing it. Email services. Gmail represents cloud-based email. Pay only for storage used. No server management required. File storage. Dropbox, Google Drive, iCloud, originally built on AWS infrastructure. Streaming. Netflix operates entirely on AWS, provides video on demand cloud service. Cloud deployment models. Private cloud example providers. Rackspace, single organization usage, not exposed to public complete control maintained, enhanced security for sensitive applications. Nota: beyond our course scope, but important to acknowledge. Public cloud. Major providers: Microsoft Azure, Google Cloud Platform, Amazon Web Services. Our focus. Features: third-party owned operated resources, internet-delivered services. 6 key advantages. Detail below. Hybrid cloud combines private and public models, maintain some on-premises servers, extend capabilities to cloud. Benefits: control sensitive assets privately, gain public cloud flexibility, achieve cost effectiveness. Important for certification exams. 5 essential cloud characteristics. On-demand self-service. Users provision resources independently. No provider intervention required. Broad network access. Resources available over standard networks. Multiple access methods supported. Multi-tenancy and resource pooling. Multiple customers share infrastructure, maintain security and privacy. Physical resources service many users. Rapid elasticity. Quick resource acquisition release. Automatic scaling capabilities. Measured service. Precise usage measurement. Pay for what you use model. 6 key advantages of cloud computing. CapEx to OpEx shift. Convert capital expenses to operational expenses. Eliminate hardware ownership. Reduce total cost of ownership. LTCO. Massive economies of scale. Collective usage drives price reductions. Provider efficiency improves with scale. Eliminate capacity guessing. No more over provisioning just in case. Scale precisely to measured needs. Increased speed and agility. Immediate resource availability. No operational bottlenecks. No data center maintenance. Remove physical infrastructure burdens. Small teams can deploy globally. Global infrastructure benefits. Worldwide resource availability. Minutes to deploy international applications. Problem solved by cloud adoption. Enhanced flexibility. Adapt quickly to changing needs. Improved cost efficiency. Optimize spending. Superior scalability. Grow resources with demand built in elasticity. Scale out and in seamlessly. High availability. Multiple data center redundancy. Fault tolerance. Built-in failure protection. Development agility. Rapid software lifecycle. This comprehensive cloud model makes adoption an obvious choice for modern computing needs. In our next session, we'll examine the different types of cloud computing services available.